That's on me.
Kev.
So
He doesn't get mad about it.
one of Jed's nieces' names was Rebecca. It was his brother's daughter. So she was Rebecca Lazari. My name's, Becky Lazari, but probably on my little thing, my proximity card, I'm pretty sure it probably says Rebecca Lazari. Some of you know my login is R Lazari. So it was really odd at first. So like Rebecca came into town and borrowed my computer to look up something for her flight home or something. And I didn't know her very well yet, but she and my, I don't even know what she is, stepdaughter, Audrey, I love her. Anyway, Jed's daughter, they stayed in my apartment, and so Rebecca Lazari borrowed my laptop. And then about a week later, I go to log into Gmail, and I was like, why are there two Rebecca Lazaris here that are coming out? It was a little bit shocking because I'd forgotten it. At first, I'm like, what is happening? Like, I couldn't figure it out because my login is also Rebecca Lazari on one of my Gmail accounts. And so that's very confusing. It's not what we call a one-to-one function. She since she really goes by Becca more, and she's gotten married, so now she's Becca Nelson. But I just found out there's another Becca Nelson. There's one in Jersey. I signed up to go to a conference with my daughter-in-law, and I saw the list of people attending, and I'm like, oh, Becca Nelson's going to be there, awesome. But it was not the Becca Nelson I was expecting. I wasn't expecting her. And she was not there. I kept looking, and I'm like, I finally asked somebody, where's Becca Nelson? And they're like, it's not her. Okay, so it's now the chances that Dakota is going to run into another Dakota Virage, but I would have thought the chances of this were pretty slim also, okay? And so then if Becca did not marry, whatever his name is, I forgot her husband's name, but anyway, Mr. Nelson. Then we'd both go through life in the same family with the same name, and it would be a little bit confusing because we live in different states and we do different things and we're technically not even blood related. It's just would be a little bit confusing, but it's not the end of the world. But you could go, suppose you worked at Marymount. That'd be even more confusing, okay? So that's what's happening with our trig function. If somebody handed you something, say Dr. Dyke said, take this to Miss Lazari, you'd go, which one? Well, Rebecca Lazari, okay, which one? Email it to rlazari@marymount.com. They'd have to come up with, the Sarah B. Sullivan.
So I was just about to say,
like middle school, Miss K. White and then the Latin teacher.
Oh, yeah.
So you have to find a way around it, okay? So these functions, linear functions, have been easy for you to solve. They've been easy for you to undo. If you have 3x minus 4 equals 7, the one reason that was so easy is because it's what we call a one-to-one function. The purple and the black both pass the vertical line test. But your algebra teachers probably mentioned this to you. They also pass what's called the horizontal line test. The horizontal line test is kind of a pre-vertical line test. This test, the vertical line test is testing to see if anybody has the same first name, for lack of a better way to explain it. In other words, it's testing to see if any of your x's repeat, okay? So I got too much on this graph. Let me get rid of that. All right, so let's look at 3x minus 4. Must look sort of like that, slope and y-intercept and stuff, okay? Is it a function? And as I go through here, okay, you can see that it doesn't ever touch more than one x at a time. So it passes as a function. So it functions really well, but what this checks is to see if its inverse is also going to function very well. Do you see my y's also don't repeat?
Yeah.
So it means everybody has a different first name and everybody has a different last name if we talk about names, and it's super easy to understand if we have a class like that. I can say Ava and nobody gets confused, but I have some other classes where I've got to have gimmicks to where they know, who I'm talking to, okay? So everything's fine right now with, you probably say Grace and, what's the other Mary? Megan. You probably actually call them Grace and Megan, okay? But later on in life, they might be referred to as Ms. Murray or Dr. Murray, and then it could be confusing, especially if they work in the same place. or live close to each other or whatever. Do you see that could be confusing? There's a lot of graces, so that doesn't even pass the first test.
Yeah.
Do y'all see what I mean? Okay, so what we wanna know is when we switch those names, if your x's become y's, is your inverse function still gonna work? The first time you ran into it, lines were easy to solve. When does 3x minus 4 equal 7? You add 4, you divide by 3, you get one answer, you know when it happens, everything's la-di-da fine, okay? But the first time it became kind of an issue for you was when you square rooted, okay? That's because this is a great function. Negative 3 squared is 9. 2 squared is 4. I can just stand here and say things like I can in a little while. Sine of pi over 6 is 1/2. I have no worry about that, okay? It functions very, very, very well. If it doesn't pass the vertical line test, I learned that so early in my career I didn't realize how profound that was. If it's not a function, it's gonna be hard to deal with. It won't literally function. They named that the way they meant to. It won't function very well and you'll be really confused as to what to do. Okay, girls? Now, is it 1-to-1 though? What happens is I drag this up here.
There are two places.
So do y'all remember finding inverses in algebra when you switch your x and y? Okay. What's the inverse of squaring? Square root function. All right, so here's the issue. What's the answer to this question?
Oh, it's 5 and negative 5.
Right, Brand can't just go 5. I can't just say, I don't know the other Graces in your class's name.
Grace Nancy.
Oh,
Grace
okay.
Fitzsimmons.
Yeah.
Grace Berger.
So,
We're 5.
Oh,
Grace Clark.
How do
Grace
people
Nancy.
in our grade 61?
Grace Berger.
Yeah.
Grace Murray.
Grace Fitzsimmons.
So 5 out of 61 people in our grade are
I too in my honors pre-cal class. And so if I say, who's named Grace, you'd have to say Grace Murray and Grace Hooper in my honors pre-cal class, okay? So anyway, Brand's right. She's got it say 5 and negative 5. Are those equally acceptable answers, girls? Yes, they are.
Yes.
Now, what happens with this though when I get on the inverse function? Did y'all see this wasn't 1-to-1?
Oh yeah.
So what if I have x is equal to the square root of 25? A very
only
similar,
5.
it's only 5. The only answer to the square root function is 5. Really hang on. It looks like y'all are really paying close attention. What happened back in the day, back way before computers and stuff, they had to deal with it. The funny thing is now in 2020 with all our super advanced technologies, it's advancing super rapidly. I think a new iPhone comes out every 13 seconds. But all of this didn't go away. They didn't find a solution to, we can make this easier. We're still in the same boat as far as to what they did for thousands of years. So when you're gonna find the inverse, like how to undo squaring, okay? They looked, and that's, if you're gonna switch x and y, these y values are about to become your x values, and that turns on its side this way, and all of a sudden it doesn't function anymore, okay? That may not disturb you a whole lot, but they had to define what they're gonna do when they push the square root button on your calculator. They didn't know there was gonna be a calculator. They just had to come to a consensus of, if somebody says, what's the square root, they didn't want you to have to give 2 names in a given situation. We've talked about this a little bit in here already before. You remember how we talked about 4 plus the square root of 25?
Yeah.
You would definitely call that 9. The square root of 25 is 5. So back in the day, they had to pick. They could pick yellow or red. If they pick yellow passes the vertical line test, doesn't it? It will function. Sorry. If they pick yellow, doesn't yellow pass the vertical line test?
Yeah.
All by itself, okay? So let's move this out of the way. All right, so yellow passes the vertical line test, doesn't it?
Yes.
All right, and all by itself, red passes the vertical line test.
But
Together, this is really the inverse of x squared. I'm not gonna get too much deeper into this, but what they found when you use the square root function, used to be probably even on tablets or in the sand, eventually paper, and then on our calculators, they just want one answer. And so they had to pick, do we want the yellow or the red? Well, if you were the one in charge of picking, what would you pick? What do you think people need the most if they're square
Yellow.
rooting?
Yellow.
The yellow. I teach, often people or sit next to Mr. Hill. Mr. Hill would pick the red. I don't think he'd mind me saying that. He'd go, oh, I think I'm just gonna pick the negative square root of x. And you're just gonna go, stop. Because you're not gonna need that one very much. Many times you're square rooting because you want the side of a triangle and it's positive. In construction, people have to square root to find the size of a beam that they're gonna put in a roof. You're almost always gonna want the yellow one, right? Okay, so do y'all see that the problem comes, and that if you have don't have a one-to-one function, so much of things that maybe that you haven't thought about unless your Algebra 2 teacher said it, there's a lot of functions that I can't even undo. Look at this. X cubed minus x squared plus 7 equals 0. Help me solve that.
X
I
plus
can't factor it.
equals zero.
I can't factor it. It doesn't have anything in common. I'm gonna do this, maybe move the 7 over. Good, I can't even do that. I literally can't. I'm not gonna go, oh, so you would do this. Girls, I could factor out an x, and that gives me an x squared. That gives me x minus 1. Hang on. But you don't set this equal to negative 7 and that equal to negative 7. That's not what you do, okay? You only do that when you have 0 on the right-hand side. So do you see I can't solve this for x?
Yeah.
I don't know what this one looks like, but there's a great chance it looks something like this. It is a function, but is it one-to-one? So do you see, if it's not one-to-one, we're like, oh, I don't know what to do. And some of it we can compensate for, like a square root, and some of it we can't. Here's a good one.
Yeah, what about this?
My calculus students are facing this right now. You will also. Absolute value of x, okay? It's a function, but is it one-to-one?
No.
No. And what if you are trying to solve this? The absolute value of x minus 1 equals 6. Is there anything you can slap on there to get rid of the absolute value?
What?
Does it have an inverse function? What would you do for this? 3x equals 6. Multiplication, you would divide. Addition, you would subtract. Squaring, you would square root with care, okay? Knowing that your first answer is just giving you a start, okay? Absolute value, raise your hand if you know the inverse function for absolute value, because I desperately need to know it, and then run downstairs and post it and make tons of money.
Is it negative?
There's not one, is my point, okay?
You
You haven't, nobody's
I know
got,
it. No, I'm kidding.
girls, nobody's got an inverse function for
You
absolute value.
practice so good.
All right, we need to keep moving. Nobody's got an inverse function for absolute value. Nobody's got an inverse function for something when it gets this complicated. Trig is so important that they had to do something, okay?
Yeah, how does
But
it work?
talk about, if I say sine of theta, if I say sine of pi over 6, you can answer all day long, 1/2. Your sine function looks like this. Please pay attention, girls. This theoretical discussion is going to help you understand what's going on. I'll leave it behind in just a minute, but you really want to get this. Sine of pi over 6 is 1/2, okay? But it's really tricky if I say the sine of what angle is 1/2. Pi over 6 comes to mind, but aren't there how many?
A lot.
A lot. How many?
I think every
An
quarter.
infinite amount, right? Even I could go forward and backward, finding all of these that equal 1/2. Do y'all see what she's saying?
Yeah.
So it's interesting enough, thank goodness in the year 2020 they didn't find a way to do it, because if they programmed my calculator and I pushed inverse sine 1/2, I'd never use it again. Because it would be spitting out everything it could think of. So what we want is a lot like a square root. If I ask you this question, find the answer to this for me, okay, girls? You ready? Find the answer to that. What are you reaching for?
Calculation.
Okay.
This looks great. How does a sine graph pass a vertical line?
I'll show you.
33.36.
Or negative.
Or negative?
Okay, But that's not what your calculator says, right?
It just says
It is.
Your calculator says 33.36. Your stupid calculator that doesn't have a brain, okay? Your
See it on the
girls, listen. Your stupid calculator doesn't have a brain. The reason I'm calling it that, obviously I'm being a bit facetious, but it is stupid. It's like a brick. It doesn't have a brain. It was programmed by somebody with a wonderful brain, but that calculator can't see what you have. You literally asked it this, did you?
Yeah.
Is that what you asked it?
Yes.
It didn't see the original question like you did, and some of y'all realize, oh, the answer is you had to embellish the answer given the question that I asked, right? So your calculator gave you 33.36, but wouldn't negative 33.36 work also?
Yeah.
So you gotta look with your eyes and see what I asked you. If I ask you this, you have to say 4 and negative 4. What pops in our mind first is 4. But negative 4 is 50-50, okay? But what would you say if I ask you like this? You only say 4. You follow the rules of the inverse. Remember your parent functions? The square root function is only positive. Do y'all remember that square root of x graph?
Yeah.
Okay. All right, so what's going to happen is you're going to have to look and see how the question was asked. Like this. So if I say sine, which you saw in the video if you watched it, sine of x equals 1/5. I have no idea, like literally. I'm going to have to grab my calculator because that's not one I recognize. And I'm unfortunately going to have to push inverse sine. And is it going to give me all the answers I want?
No.
It's going to give me a start. It's sort of like it's going to hand you a reference angle or a hint. Okay? But what if I ask you this? Inverse sine of 1/5 equals what angle? At that point, I only want one answer. Do you see I've got you on the inverse function now?
Yeah.
All right, now I'm going to answer Bryn's question, but I also need this graph again just to show you what I wanted to show you. Okay? All right, so hang in there because I'm going to move kind of fast. A Bryn vertical line test definitely functions. It never hits more than one point at a time vertically.
Oh, got it.
It is a function. Girls, listen, shh, it is a function. Okay? Things that don't function is you fill in something like pi over 6 and you get more than one answer. But if I say sine of pi over 6, I get 1/2. Okay? All right, now,
What about the horizontal?
is it 1-to-1?
No.
Horribly not, right?
Because there's an infinite amount.
Look at that.
of-
Hang on, Bryn, okay? Thank you, though. Is it a 1-to-1 function? You want to go, heck no. It's bad, right? And so they sat around a long time ago, but wait, we need to find this angle. We want to make this pyramid or whatever it is that we're making hundreds of years ago. And up until today, they go, oh, we need to put this beam at this angle. We need to put this satellite at this angle. And we know the sides, but we don't know the angle. So we're going to have to put an inverse sign. Are y'all with me to find that angle? And it might not give me what I'm looking for, but at least it's going to give me some help. So what they did, Bryn, since it's not 1-to-1, is the only hope of making it work is this. What did they do with x squared? Which side would you pick to flip over? Wouldn't we all pick this one and turn it on its side? If you're a logical person, you would pick the positive. So we're going to be a logical person, and we're going to pick a part of the sine wave that functions both ways. It'll pass the vertical and the horizontal line test to help us figure out something. Can anybody find a little sliver? Like I took half of that one. This one I can't even take half of it. I can take a little sliver that functions for me and that covers everything I need to have. The range of sine is -1-to-1, right?
Could you do like the like for when it goes up and down and just do that?
Yeah, I need like this one.
Yeah.
Okay, that's a great start, girls. That functions, but it's still not 1-to-1, is it? But that's a thank you for starting us.
Just the
Oh, yeah, just like kind of like where the cosine would start, but like not at the, you know what I mean? Like at the
do
top.
tangent. Oh, this.
Like
Well,
where
we're
it
on
goes
sine right now, but
Yeah,
yes.
but like that's like.
I think
the-
that's what y'all are saying, like this.
Yeah, through the middle.
Yeah.
All right, that's what they did, girls. I don't know if Ava and Julia, maybe some of you are on the right track there. That covers everything I'm gonna need to know. And after that, it repeats itself over and over again, okay? I gotta be smart enough to get the right answer. So, girls, isn't this negative pi over 2 and this pi over 2? I mean, you agree with me if you start to think about how you graph sine functions.
Yeah.
So just, this is negative pi over 2, and this is pi over 2, and you go through 0. That's why in the video, if you watched it, I told you inverse sine can only come from quadrants 1 and 4. It comes through 0 this way. This is like negative 90 and positive 90. And you can only pick right here, okay? So suppose this happened. A real, real life situation. Suppose you had this, okay? And there's like a wonderful prize that you want right here. And you're right here, okay? If there's a cliff right here, a cliff, okay? And you want that blue X, how are you gonna get to the blue X? Are you gonna try to go around positive? What just happened to this red X? It just fell off a cliff, right?
Oh.
Okay, it was catastrophic, like something bad happened to it. So wouldn't you just go down here and get the X?
Yeah.
That's what I'm saying. Okay, you're not, I'm not gotta make a big deal about it. Because every now and then a student is upset on multiple choice or on a test when the answer is negative 30 and they wrote 330. Do you see you can't go over there? And hopefully in all of this discussion is because you're venturing over part of the graph that's not one-to-one, okay? All right, let's look at, tangent does the same way, Ava. It's same quadrants if you watch the video and add it to your memo page. If you didn't, you need to go back and do that. All right, now, what about cosine?
It's positive there.
Yeah. So that's not gonna help much, is it, to stay right here? So are y'all okay if I go this way and cover at least one squiggle? And that little squiggle keeps repeating itself over and over again. That's 0 to pi or 0 to 180. All right, so on your memo page, you should have this, and we'll abide by this. If you were on an inverse trig function, arc sine and arc tangent, both can only come from the first and fourth quadrant because of the picture that they make. And the only way you can get there, it's like these don't exist, okay? If you go that way, you just fell off a cliff, okay? Sorry that's so dramatic, but I'm trying to really make a point there. If you have inverse cosine, it can come from the first and second quadrants. That's what we're gonna pick from. Okay, so before I go on, any questions on homework? Like I said, hopefully you checked your answers. Questions?
So for the answers like 5 through 13 in the back of the book, it had us, the answer was in like radians, like pi over 3.
I think I wrote to do it in radians on the homework.
Okay.
Yeah. So
Did I say in radians on the homework? Did you answer in degrees?
Yeah, I
And then
didn't see
check,
the
well, I mean,
radians.
hopefully on the exam, it was
Yeah.
in radians, you can do that.
Part of the
Okay.
video was in
can you
this,
explain one more time why it's like? Can you explain one more time why it's like that? Like why can't you?
You mean like why all of that is set in
Because
stone?
the shape of it.
It's because, the cosine wave goes on and on and on, or any of the waves. You know they go on and on and on. I just made you graph 2 periods, but they go on and never stop, okay? And so, if you're looking for an angle that gives you a cosine of 1/3, I'm gonna have to ask my calculator. If there's an infinite number that will give me a cosine of 1/3. I think my sleeve is touching that. There's an infinite number of answers that give me a cosine of 1/3. Do you see what I mean, Julia?
Yeah.
Okay. So there's no way they could program it to do that. It's just like there's 2 numbers I squared to get 16. It's even worse here, okay? And so what we would logically pick is probably this first one that we come to that way. And so, but they also want to give us a way to give every positive and negative ratio that we could encounter.
Oh, okay.
So at least you're going, thank you for giving me a reference angle. When you push inverse sine, inverse cosine, or inverse tangent.
Yeah.
So it abides by this, just like a square root abides by just this
Oh,
piece.
okay.
Does that help
Yeah.
some?
Yeah.
Okay. Now, I've tried to explain why. Ultimately, you've got to memorize it and abide by it. But my big point, it all depends on how you ask the question, okay? So that's a big deal. Alex?
Then when you include arc, is that like
It's the same thing. It's just
so
two
it's
ways
just
to
like
write
the
the same thing.
negated part?
Oh no, arc sign and inverse sign, those are exactly the same thing.
Okay.
It's just like if I said 5 divided by 2, or 5 divided by 2, or 5 divided by 2.
So it's just
Inverse
another way
sign
of
and arc
writing it?
sign, it just, sometimes I don't feel like when I'm typing, I don't feel like in my font going up and making a superscript.
Okay.
And so instead I can just say arc sign, and it's just two different ways to say the same thing.
Yeah. Okay.
Okay? Just like multiply and product
So, yeah.
means the same thing.
Okay. Okay. Cool.
Okay? Alright, so those are interchangeable. Alright, now I may be out of cat slides, so we're just gonna venture onto these slides. Alright, so we're pretty good on time. Let's see. Where did the sheets go that I brought in here?
No,
Well,
they're
there's
sick.
sheets to do and they just have disappeared off the face of the
I
earth.
always used to like see like the, like if I saw like this,
Sure
I
there.
mean, I'd initially, like, I'd always just think like 5 divided by 2, right? And now when I look at that, like,
Okay,
initially all.
so here's what I'm saying.
5. Which is
so-
weird.
On 0 to 2 pi,
Isn't that so weird?
find all the solutions for this. Okay? So help me with this. On 0 to 2 pi, find all the solutions. So what I'm gonna have to do is go to my calculator. I'm gonna do this in radians. It's a little easier in degrees, so I'll do it in radians. Alright, so I'm in radians. So girls, aren't I gonna have to at least ask my stupid calculator to give me some help here? Cause I don't even know what angle to start with. Okay? So I'm gonna have to push inverse sine or arc sine, inverse sine of 1/5.
It's a monstrosity.
And I get 0.201. Alright, so one of my angles is 0.201 radians. It just went like this. It went through the first quadrant, and it found an answer, and it spit it out, and it goes, I'm gone, I quit. Okay? But isn't sine also positive over here?
Yeah.
And my stupid calculator doesn't know that I was actually on the sine function where I've got to keep going. I'm not on the inverse sine function. Nobody put me there. I put myself there for momentarily, but I see the question. Okay? So since the question's worded this way, I got to keep going. So I'm going to subtract this. If it was degrees, I would subtract from 180. But since it's radians, what am I going to subtract from? Pi. All right, so I'm going to say pi minus, where's pi? Pi minus second answer. And another answer is 2.9402. So theta could also be 2.9042 or whatever I just said. I hope I said the right numbers. Stay with me, girls. Both of those work. Don't they have the right to both be up there? Now, why didn't I keep going? Because from 0 to 2 pi, aren't these negatives? Okay? It's going to be a really big deal as time goes by, so just watch, okay? And so that's why we do it the way that we do it. You've got to really look at how it's worded. Now watch this. Similar to what I had done the other day, if you saw the video.
Wait, Mrs. Derry,
Yeah.
what is second answer?
You don't have to use that. You can just like go up and copy the,
Okay.
you've got to pull that number down. In the old days, they owned the calculators. You got it? You can just go scroll up to it and hit enter and it'll bring it down.
Okay. Oh, interesting.
Where is it? Inverse.
I got 2.9402.
Yeah, I may have written the number down incorrectly. I wasn't sure. I was moving so fast I didn't double check to make sure I'd written every single number down correctly. All right, so on this, I don't think I can write on it. I'm going to try. These say arc cosine, or like Alex was saying, inverse
Oh, you
cosine.
can draw. It's up there. It says draw. The third one next to design. That should work.
Yeah.
Wow, very nice.
Okay, thank you so much. All right, I think to myself, I can only be in quadrants 1 and 2. Arc cosine, cosine is positive in quadrant 1. So I go through here and I find pi over 3 or 60 degrees and I'm done. If I say inverse cosine or arc cosine, they're interchangeable and I only want one answer, if any. Sometimes you get no solution, okay? All right, so those are the rules, just like square root. All right, arc cosine of negative 1/2. Arc cosine can come from quadrants 1 and 2. I don't know what's happening with all that blue. Arc cosine can come from quadrants 1 and 2. So here's my calculator without a brain going, do. It didn't find anything, because what's cosine in the first quadrant? Positive, so do you see it has to go into this?
Wait, why did I
You're
do
trying to
that?
find the cosine of an angle that gives you negative 1/2. So you're going to have to venture into the second quadrant, aren't you?
Yes.
And so you'll get a 60-degree angle in the second quadrant, which is 2 pi over 3.
But I see.
What's this?
Not writing very well.
Oh yeah, cosine.
Girls, give me your full attention for the last few minutes, okay? Bryn, did you have a question?
No, I was just thinking to myself out loud. Sorry.
Okay. I did this on the video also. Just because it says inverse tan of tan doesn't mean those are going to cancel each other out. You better work it out. So I have arc tan, arc tan, and I'm going to work this out just like on a memo quiz. The tan of 315 is negative 1 if you had it on a memo quiz. Now I'm on the arctan function like this. Arctan can come from quadrants 1 and 4. Are you going to find it in quadrant 1?
No.
So you're going to have to drop down into quadrant 4 at a 45-degree angle. And so I would say negative 45 degrees. Okay? And you could actually type it in your calculator and it would say negative 45 degrees. So just work it from the inside out. Okay? All right, now moving on to some of these others. Arc tan of root 3 over 3. If you see arc or inverse tan, it can come from quadrants 1 and 4. Where are you going to find this one, 1 or 4? 1 at 30 degrees or pi over 6. Okay? If I was doing arc secant, I wouldn't. I would make it arc cosine. That one's undefined actually. That would become arc cosine
-2.
of negative 2. Can cosine go that far?
No.
Cosine is opposite over adjacent. Or you can think of the graph. Sorry, that's not what cosine is. Cosine is adjacent over hypotenuse. Is there any way for this to be adjacent and this to be the hypotenuse? So this one was no solution. You can get no solution. Pretend like that says no solution. I'm tired of this. Okay? Look at this one. Arc cosine of 4/5. I have no idea what angle gives me a cosine of 4/5. But this is like some other homework you've had. Watch this. I'm going to draw a triangle. Arc cosine can be in quadrants 1 and 2. Which quadrant am I going to be in? 1 or 2? My unknown angle. Arc cosine of 4/5.
2.
What's cosine in the second quadrant? Negative.
Oh, so what? So it's gonna be.
So it's got to be in 1.
Yeah.
That's why like go into 1 and 2 because it's positive here and negative there. It at least gives you a way to get all your answers that you're going to encounter. All right, cosine's positive 4/5, so y'all might remember doing this a few times. I'm going to draw a triangle. I have no idea what the angle is, but I know the adjacent is 4 and the opposite is, the hypotenuse is 5. And so what is the opposite side over here? 3. And even though I don't know what in the world this angle is, I can actually find the sine now. It's 3/5. So look at what we just did here. Arc cosine of 4/5. Girls, we could pause and get out our calculators and go inverse cosine 4/5, and it would give me an angle. okay? And then once you have that angle, what are you gonna do? Take the sine of that angle, try it. So inverse cosine of 4/5. And after you get that number, take the sine of that. Do you get 3? You should get, 3/5, thanks. That's 0.6, 6/10. Okay? But do you see I did it without a calculator?
Yeah.
So you've done these little triangles with Pythagorean theorem before. All right, now, the last thing I want to show you before we leave, because I've got 3 minutes, is you're going to have some problems that are a little bit more involved to solve. So you'll see some problems like this, like 4 cosine squared x minus 3 equals 0. All right, now this says solve on 0 to 2 pi. So I don't have to do that plus k is any integer thing right now. It just wants one cycle, okay? Just get me started. What would you do first?
You would add the plus 3.
All right, so we're going to add 3.
Oh.
I think my shirt is wreaking havoc on this. All right, so you have 4 cosine squared theta x equals 3. Cosine squared x equals 3/4.
Yeah.
Square root. You're going to have to be smart enough to realize you were on this function, so you should say plus or minus. What's the square root of 3? I don't know, but what's the square root of 4? 2. And it's like, oh my gosh, I recognize that number. That's at this 30-degree angles, but I'm doing it in radians. So since it's plus or minus, wouldn't I grab all of these?
Yeah.
Okay. So all of these 30-degree angles would be good practice for you in radians. It's pi over 6. This one's 5 pi over 6. 7 pi over 6. Sorry. Travelocity. 7 pi over 6. And 11 pi over 6. Okay. All right, I need to do another one before we go. What about one like this? Cosine squared x equals 1 minus sine x. By the way, a couple of you aren't writing your squared in the right place. If I say cosine times cosine, that means cosine x quantity squared, but we write it like this. The little squares in between the s and the x. What in the world am I going to do?
Oh, minus the, that's like one of the identities.
Almost.
But it's
Using
a
a
little
square,
bit,
yeah.
Okay.
It's different.
I'm going to change cosine squared into 1 minus sine squared. That way at least I have all the words sine in it, okay? I'm sorry, Alina, what?
Can you do the 90 degrees?
I don't know what you're talking about. Say it a little differently.
The co-function identities.
Oh, yeah, well see how it's squared? You want to go straight to your Pythagorean identities? There is something with sine of 90 minus x, but we don't have that here. But that's great, she's got to memorize, so you make sure it's like a key turns and you at least think to look it up. What I need to teach you in 30 seconds or less, okay, is it's good to get it all one word, and the cosine squared was easy to change. Now I'm going to get it equal to 0. I'm going to move everything over here. Sine squared x minus sine x. What happens to my 1s?
It's 1 minus
My 1s cancel, okay? Then you might have to factor tonight, all right, over the weekend. Okay? What's your first rule in factoring, Kate?
Take it with the phone.
What do they have in common?
Sine.
Sine x. And this gives me sine x minus 1. And then what do you do with your factors? Set them equal to 0. That'll give me sine x equals 0, which happens at 0 and pi. And what will this one give me? Sine x equals what? Sine x minus 1, it'll give me sine x equals 1, which happens at pi over 2. And here's all my answers. So you can be packing up. All you've had to do so far is linear ones. But you see you might have quadratics. So you might have to factor. And I'll see if I can find some good delta math on this, because it also can give you more examples until you get the ones done that I want you to. But I'll post the homework. Remember your exam review's up.
Does that have everything that it like?
Yeah,
not
in fact,
any
if,
more?
in fact, we may not get to all of it, in which case then I'll let you know. But right now, if you encounter something that says law of signs, just skip it.
Okay.
If it doesn't sound familiar to you, just skip it.
Okay.
Okay?
Thank you.
I
I love
you.
presentations like these. Oh, my God, it's probably-